Tell me something good. I don't know the rest of the words of the song. I'm sorry. The goal of this video is to learn to calculate binomial probabilities. So I want you to not take notes on this next slide. So there's the scary way. So to find the probability that you have the number of successes equaling k. Well, sorry, you should take notes on this. That's what we're finding. So that's the probability that P, guess what that stands for? That stands for the probability. That's the number of successes wow. There we go. And then is k. You could have greater than k, you could have less than k, but in this problem it is k. And I'm going to show you the formula. That is n, choose k, times p to the k, times 1 minus p to the n minus k. I'm going to take a wild guess that you're not a huge fan of this. I will gladly show you this elsewhere, and I'm sure you can find a trillion Khan Academy videos about how to use this and how to calculate that. Instead, I want to look at the less scary way. I want to look at the calculator way. So how do we calculate the probability that x equals k? And we're going to look at this as an example. Okay, so we need a question associated with this problem. So let's try to calculate the probability that x is, let's say, 2. So what we need to do is figure out x, the number of successes, equaling 2. That means we're going to get 2 correct. So in context, exactly 2 answers correct. So exactly 2 out of 4 are correct. Let's not write that as a fraction, that might confuse you. 2 of 4 are correct. So on your calculator, what we want to enter is binom PDF. And then in the parentheses, what we're going to do is 4.2 and 2. So you probably want to know how to get that in your calculator. So to get binom PDF, what you're going to do is hit the second button. Then you're going to hit the vars button, which right above it says distr, which stands for distributions. And guess what? There's distributions under distributions. Then we're going to scroll down, and you'll see binom PDF. And then, once you've done binom PDF, hold on. Alright, and then you'll see binom PDF, you'll press enter, and then it will either ask you for trials, probability, success, or number of successes, or it'll just give you an open parentheses. What we need to enter is binom PDF, and that is the number of trials, n, the probability of success, p, and the number of correct trials, x. So in general, this is what you enter to figure out that probability. Alright, and when you press that in your calculator, you should get 0.1536. Let's take a look at a practice problem. Let's say you're shooting free throws, and let's say you're a 70% free throw shooter. What's the probability that you make let's say, I don't know, 9 of 10. So pause your video and answer this question. All right, assuming you've paused your video, first thing you need to do is say this is binomial. If you haven't done this, then shame on you, but good thing that you're learning. So binomial with n is 10, not 9. 9 is the number of successes we want, not the number of trials. And the probability of success is 0.7. So what we're calculating for is the probability that we get 9 free throws made, which is binom PDF 10, comma 0.7, comma 9. And you'll find the probability that you'll see is approximately equal to 12.1%, or 0.12. Okay, let's look at one other type of problem. Suppose we're doing the same thing. Let's suppose the probability of success is 0.7. The number of trials is 10. We want to know what is the probability that we make less than 5. Okay, so this less than 5 changes the problem drastically. So we're still going to say it's a binomial distribution with probability of 0.7. Write that out. Binom P is 0.7, N is 10. This time we're calculating the probability. And notice in this part, probability is uppercased, where this is lowercase. I know it's hard to tell because the paper isn't lined. We want to know the probability that x is less than 5. All right. So here's what we need to do. Your calculator does something called binom CDF. What binom CDF does, and let me open up a new page. This is right next to PDF. CDF means cumulative. And that's not the probability that x equals k, but the probability that x is less than or equal to k. So what we need to do in order to use this problem, so binom CDF is n, p, k as well, we need to make the problem look like that. So, probability that x is less than 5, that's the same as the probability. So if you're making less than 5 free throws, that's the same as making less than or equal to 4 free throws, which is binom CDF of 10, 0.7, and 4. So throw that in your calculator. So the probability that you shoot less than 5 made free throws is approximately 0.047, which is 4.7%. Let's look at the same problem. Probability of success is 0.7. N is 10. Let's find these probabilities, and I'll let you work through this. So let's say, all right, so the first question we want to answer is, what is the probability that you make at most 8 free throws, then less than 6 free throws, and then more than 7 free throws? So pause your video and answer these questions. All right, assuming you've paused your video and worked through these, let's take a gander out yonder and see what the solutions are. So for the first one, we want to know the probability that we have less than or equal to 8 free throws made. Right, so at most is saying I could have 8 and I could have less than that. So that's why it's x less than or equal to 8. So this one should have been rather straightforward. Since you have it in the x less than or equal to 8 form, we can go straight to CDF. This next problem, however, states the probability that x is strictly less than 6. This is different because 6 is not a possible solution. We have to write this in a less than or equals to kind of way. So now it's the probability that x is less than or equal to 5, which is binomial CDF 10, 0.7, 5. Once you've rewritten this as the probability that x is less than or equal to 5, or x is less than or equal to 7, or x is less than or equal to 8, then the rest of the problem is easy. All right, so for number 3, we're looking at the probability that x is greater than 7. So we need to make this a less than. So either you're greater than 7, or you're less than or equal to 7. Right, there's 3 cases. You could be greater than 7, you could be equal to 7, or you could be less than 7. So the complement is 1 minus the probability that your x less than or equal to 7. So that's binomial CDF 10.77. But one thing we have to add in here that's a little bit different. Since this is 1 minus, we have to do 1 minus that binomial CDF. Right, so that 1 minus we can't forget about. Let's get rid of that. All right. 1 minus the binomial CDF. That 1 minus. You can't ignore it. Can't ignore it. All right, so hopefully this helped you calculate binomial probabilities. Up next is calculating geometric probabilities.